Today we are going to see lines of best fit. This is the chapter 10, lesson 3, which is the last lesson for this chapter. And today we are going to draw lines of best fit and use them to make predictions about data. So what are we going to do is, but let's do just a very quick recap. We have seen what scatter plots are. And scatter plots are points that usually don't form a perfect straight line. So you see all this information here is not forming a perfect line, but still they have information that we can make conclusions, we can create information about this and come to conclusions about some points and the data that we have. So we have seen this before, and now we're going to see how to put all these little dots here that are not in straight line, how to get the best information and make a line from them. So here we are, lines of best fit. The lines of best fit are the line that is closest to all the points. So here, see, the points are not aligned, but we are going to get from here, we're going to draw the best information possible. And here, see, we also have points that are not aligned, but there is a line that is called the line of best fit, which is the line that might contain the most information about the points that we have. This line here, it does not contain all the points. So it is impossible to make a straight line containing points that are not aligned. Like we can see here, the emails per day, look, the points are all scattered. That's why they are in a scatter plot. And here we got the best fit line to describe this information. How do we do that? So let's take a look at all these examples and let's see how we work on that. So the lines of best fit, they are used to what? Predict future points by either looking at the points on the graph, which is the example we are going to see next, example number 1, or plugging values into an equation. So here we are going to be reminded of how to use the y-intercept form of an equation, like of a line. The y equals mx plus b. So we are going to go back to that. So there will be a quick recap for you. But first thing that we are going to see is how do we do this using points on the graph. So let's see the first example here. The first example of how to build a line of best fit. Construct a scatter plot, then draw a line that seems to best represent the data. Use the line to make conjectures about the cost of cookies in 2012. So the information that we have here is the year since 1995. So since 1995, the first year after 1995, which is 1996. Then 3 years after this, 98, and then 2000, and 2002, 2004, 2006, 2008. And this is the average cost of cookies, $2.58 all the way to $2.85 depending on the year. So the first thing we do, we get all this information here and we make the plot. So let's put the years here. The first one that we have is 96, 98, 2000, but we want to find information in 2012. So we are going to go on this graph here until 2012 so we can make a what? A prediction. So let's see, 2008, 10, and 12. We have room for a little bit more, so I just wrote a little bit more. So from 1996 all the way to, actually we just need 2012. So let's plug all these costs, the cost of the cookies, in our scatter plot here. So in 1996, it costed what? $2.58. Oh, we need to do this as well. So The smallest amount that we have is $2.39. And the highest value for the cookies is $2.88. So let's make our graph fit that information. So here I can put like $2, let's say $2.20, $2.40, $2.60, $2.80, and $3. So I went by 20 cents over here, and I went by 2 years over here. So let's see, in 1996, it was $2.58. So my dot goes about here. Then in 1998, $2.54. So this is 50, let's say 54 right here. In 2000, my amount, $2.39. So below 240. 2002, $2.59. So I went up again. In 2004, let's see, $2.65. So this is 70, like right here, it's growing. 1 year went down, but then it kind of keeps growing. 2006, $2.88. So 2006, $2.88. And then in 2008, $2.85. So 80, this is 90, right here. You see how our points are all scattered. That's why this is called a scatter plot. So we have to draw the line that best fits over here. Our points in general, they are growing. The cost of the cookies is in general growing. 58 went down 2 years, but look, this is all kind of growing. So we are going to get our ruler here and see where we can get the most amount of points in our data. So I will draw a line over here, and this here contains almost 3 of my points, and the others are closer to the line of best fit. One thing that needs to be very clear, that this line is going to go above or below for depending on what you're trying to do. You could have drawn a line over here, you could have drawn a line a little bit lower. So this is not an exact line. This is all going to be best fit. So what I see that it includes the most amount of information in my line. So for using this line over here, what conjecture or what prediction can I make about the cost of cookies in 2012? So if I come here to 2012, my year here, and I follow my line, see, if I draw the point where my line is, I am going to say that the cookies in 2012 are going to cost at least $3. So this is one conclusion that I make with the line of best fit for this example over here. Now, what we are going to do is a quick recap of y-intercept or slope-intercept form of an equation of a line. And we're going to use this with the line of best fit. So just to recap, how do we write a slope-intercept form of an equation? The equation is y equals mx plus b. We saw this, I think, in chapter either 6 or 7, so it's been quite a while, but it was in this semester. So we are going back, let's go back on our memories. So the y-intercept is the point where the line crosses the axle y. So if I have here, see, my axes are here. The point where it's crossing, this is the line, and the point where it's crossing the y is right here, which is the point -3. So I come here and I write -3. Then the slope. What is the slope again? The slope, just so we can remember, is the rise over run. Rise over run. So if I get this point, oh, let's see. From this point to this point here, what do I get? 1, 2, 3 up and 1 to the right. So if I am moving up and to the right, my slope is positive. So my slope here is 3 up and 1 to the right, which is the same as writing 3. So if I have to write this equation here of this line in slope-intercept form, y equals mx plus b, I am going to write what? Y equals mx, m is the slope, which is 3, plus b. b is -3. So the way that this line can be written is 3x minus 3. And you're going to see that we'll find the same thing for lines of best fit. The difference is that this line here that we find for the line of best fit is not going to be the same line for everybody. So equations are going to be different for each person when they are drawing this or when they are finding the line of best fit written in a slope-intercept form. So let's see an example of that. Let me erase the information I have here so we can see it very well. All right, so lines of best fit and slope-intercept form. Step 1, mark the points in the coordinate plane. So the points were given, the scatter plot was done, okay? So those points are already there. And then draw the line of best fit for the points. So this is the line that was drawn. The points were here. The line in red is the line that was the best fit. Then choose any 2 points, and this is important, any 2 points. This is what is going to give us the different characteristic for each line that we draw. So choose any 2 points on the line or closer to it. So here, the points that were chosen were these ones. This, which is 4 for x and 5.5 for y. And this one here, which is 11 for x and 11.5 for y. This is not marked, so let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Same thing over here. 1, 2, 3. Okay, so this one here is 11 and a half, right here. See? And this one here is what? 5 and a half, right here. And 4 and 11, right here. So this is the point that we're working with. Then find the slope M. So this is the slope I'm going to find, the slope M. And the 2 points that were chosen are these points here. So there are 2 ways that I can do. y2 minus y1 over x2 minus x1, or the easiest way, since I have a graph, is to count how many rise and then how many for the run. So let's see, from this point here to this point here, I am going to count rise over run to find the slope. So I went up 1, 2, 3, 4, 5, 6 until here. So 6 up, and then 1, 2, 3, 4, 5, 6, 7 to the right. So this slope is positive. It went up and to the right. So here my slope is 6/7. Then find the y-intercept, or the closest number possible. This here, look, my line comes over here. I would say that the closest number possible is number 2. So it is not exactly on 2, but I will put 2 as the closest number possible. So this is going to be the B for my line. So now I have the M, which is my slope, and I have B, which is my y-intercept. So what do I do now? I write the equation for this particular line of best fit, which is what? Y is going to be M 6/7 X plus B, which is 2. And this here is my line of best fit for this line over here. If the person that does the problem chooses a line that goes a little bit higher or a little bit lower, this equation here is going to be different. But in general, the equation has to represent the line that was drawn over here. So we're going to have one more example so you can understand that better, and then I'll assign you the homework. All right, so this is our last example, example number 2. Write an equation in slope-intercept form for the line of best fit that is drawn. So we are going to draw it. And then use the equation to make a conjecture about the number of self-service subscribers in 2015. So this is already marked over here. 2002, 4, 6, 8, 10, 12. So we'll have to make a conjecture about this year over here, 2015. And now let's get the information that we have. In 2002, 81.5 million subscribers. So in 2002, this is 85, so here, 81.5. In 2004, I have what? 93, so somewhere around here. In 2006, I have 100 exact, right there. In 2008, 105.5, so somewhere around here. And then in 2010, 97, so it went down. 95 here, 97.5. And then in 2012, 110.3. So 110.3, somewhere around here. Look, this is not a precise graph. There was one year here that it went down, but that's okay. We can still see that this is a positive scatter plot because it is growing. So we get our ruler, right here, and we draw the line of best fit. So I am going to draw the line somewhere around here. And I have to make it long enough that it will come to the year that I'm looking for, see? So look, now I have what? This is the 2015. Look, this is what I found. So here it says, use the equation to make a conjecture about the number of self-services subscribers in 2015. One thing that I can do is I can get 2 points to write my equation, but also I can just go and straight look at my graph. So instead of just solving it using the equation, I am going to solve it using the graph. What do I have here? Let's first try to find our slope. So we still have to write our equation. So I will mark. Which points can we mark? We can mark this point here, which is 90,000, and we can mark this point here, 110,000. These are 2 points where my line is going. So it goes through those points. So I'm using this point here, which is 2010 and 110 million. And this point here, which is 2004 and 90 million. How do I find the slope? I can go rise over run. So if I go rise, see, this is 5, 10,000, 15, 20,000. So from 110,000 to 90,000, so this is 20 that went up. And then how does it go on the run? My run goes like this. 1, 2, 3, 4, 5, 6. Because this is the year 2004 and this is the year 2010. So it's 6 years of difference. So here it went up 20, and to the run it went to the right 6. We have to be very aware of how much we're going up. We cannot just go up 1, 2, 3, 4 because that's wrong. Because each one of these here is 5,000. So this is 5, 10,000, 15, 20, million, sorry, not thousand, but million. So 10 over here, 20 million over here. And from here to here, it went by 1 year. So yes, from 4 to 10, it's 6. From 90 million to 110 million, that's 20 million. So this is what? My rise is 20, my run is 6. So how do I write my equation? I still need to find what? Where it crosses the line. So see, this is 70, 75, and this is 80. So it's kind of like in the middle. So I could say this is probably 77.5 million. So that's where it would be my letter B. So Y here is going to be M. 20 over 6. Can I simplify that? Yes. Should I simplify? Yes. Do I write this in mixed number form? No. So here we go. I can divide both by 2 and I get 10 over 3. And this is going to be my slope. So 10 over 3x plus 77.5. This here is my y-intercept, and this here is my slope. This is the most complicated example that we're going to have. So there is one example in the homework, so you can practice this. But the most important thing is the prediction, because now we need to know how many subscribers in 2015. So look here, if I go to 2015, what number do I see here? Between 120 and 130, more than 125. So I would say that in 2015, this is what? 125, maybe 127 million subscribers in 2015. The homework is going to be page 622 of the book. Numbers 2, 4, and 6 only. And then start studying for the chapter test. The chapter test is going to be only next week on April the 22nd, which is Wednesday of next week. Thank you for watching.